What are the best tips for improving basic math skills? I've struggled with basic math problems like calculating percentages or splitting bills since I was a kid, and I think it might be related to my ADHD. My education is in literature, and I've always avoided math, which has led to me feeling incompetent in this area. I'm trying to improve my basic math skills, and I've installed several mobile games to practice, like the Digits Math Puzzle on iPhone, where you need to reach a target number using basic math operators and 6 given numbers. For example, let's say the target number is 126 and the given numbers are 23,756,100. I find this problem nearly impossible. While my friends can solve it in 30 seconds, I spend long minutes just staring at the numbers. They are addicted to and enjoy the game. While it terrifies me, it feels really embarrassing. Practice. Memorizing basic math staples like times tables for a start. And although it doesn't directly make your IQ or mental arithmetic increase overnight, it does help. Your brain will start to notice patterns and recognize connections about numbers. Practice. 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 Find exercises on the internet and solve them. A long time ago, an educator realized that many kids have faked their way through years of math by grade 7 or 8. Honestly, the skills involved in faking math knowledge might be just as important as the math, but it makes it really hard to build on a foundation full of holes. I would recommend Khan Academy. It's free and online tutoring and testing. I suggest starting at grade 1 and doing tests till you find weak spots and then do the lessons from there. Make sure you aren't dyslexic. Dyscalculia for numbers. Sometimes the brain is resistant, and it's good to know you may need more breaks in between lessons, studying, tests. Sometimes it's not your fault for processing slowly. Everyone says practice, and yes, that is definitely the best thing to do. But finding the right way to practice can be tricky. Something that really accelerated my mathematical capabilities was attempting to explain it to someone else. As you try to explain to someone else what you're trying to figure out and break it down in a way that they can understand what you are attempting to understand yourself, a lot of times I bet you'll have a light bulb moment. Things will often click when just racking your brain alone didn't seem to help. Regular practice. I always did simple mental maths whilst walking to school, times tables, making up word problems, estimating things I saw. Try to estimate the total cost of stuff at the shops. Avoid using a calculator for anything that you can until you've tried to do it with pen and paper. Mentally. Severe mega ADHD right here. Always been bad at math. Why am I going to be interested in something I don't like? Stopped caring similarly to you. Excelled in most subjects. Sciences too. Funnily enough, my senior year I somehow managed to understand calculus. One of the few times I could grasp a B average all year. When I went off to university and tested within one below satisfactory level and essentially took a class that prepared me for uni levels. Now I work in finances. Because through working and educating I learned I'm very good at applied mathematics. School is much more theoretical. Practice and look at math like a language. Be patient, then practice more. In simple addition and subtraction that I do in my head on the fly, I always found it easiest to break it down due to the communicative properties of these problems. i.e., 17 plus 24 equals? 10 plus 20 equals 30. 7 plus 4 equals 11. 30 plus 11 equals 41, which 17 plus 24 also equals 41. It's how I break them down in my head. Don't count. Visualize. The mind of someone with ADHD can mostly see better in terms of shapes, colors, sizes instead of numbers. YouTuber 3 Blue 1 Brown explains these types of stuff. If you do want to count, you have to consider the rules to get there faster. For instance, if you want to know 5% of something, just divide it by 2. Then move decimals accordingly. So if I ask, what is 5% of 18? You get 0.9. By just dividing 18 by 2 you get there faster. 5% of 346. 300 halves equals 150 and 46 halves equals 23. That's 173 combined, then move decimals. 17.3. There are so many rules you will formulate on your own while exploring math. It's hard to memorize them, but if you yourself made the formula cause you truly understand them. No need to memorize. Things will come naturally. Make sure that you enjoy the process. In time, you will solve problems faster. Literally practice. Math is just puzzles. It's like asking how to get better at a Rubik's Cube. Watch a tutorial and do repetitions. I also have ADHD, and our difficulty usually lies in the fact that math alone isn't stimulating enough. I couldn't understand algebra until I had some context from stoichiometry in chemistry and equations in physics. Find some way to make practice stimulating and you'll get it. Consider trying math game apps or setting alarms to remind you to take a break at work and do a few problems. Try to understand why you're doing the operation instead of just what you're doing. That's why I refuse to use the term cancels out when I was teaching algebra. If you say, the 6 on both sides cancels out, that can be confusing, but if you say, divide both sides by 6 inches, it's clear what you did and the purpose it served. I like to involve my toes for the more intricate calculations. As someone who used to be in a similar boat, good at reading and writing, bad at math, I did it by basically leveraging my reading abilities for comprehension of concepts. I'll write a lengthy post that might help. For the cred of the street. Still not a math genius, but I've gotten through discrete mathematics and multivariable calculus. Try viewing mathematics more like literature than memorizing tables or mathematical facts. One of the greatest aha moments for me was when I made the realization that the rules of math are not arbitrary things made up by humans. They are laws that reveal the nature of the numbers themselves. They describe how the numbers behave in an ontological system humans have devised for understanding them. Mathematics is a literature if you squint at it. It's a history of humans grappling with an area of reality, writing their thoughts about how these strange entities behave, and determining what is or is not true through logical deduction. Part of what separates mathematics from other sciences is the fact that we can't go observe them and subject them to the empirical tests used in the scientific method. We can only tell if something is true by testing if it is consistent with axioms and logic, which is a process that we call proving. Taking a view of math like this is the opposite of how it is primarily taught. In a piecemeal, bottom-up fashion, we teach students 2 plus 2 equals 4, then 7/16 is less than 1/2, then 6 times 6 equals 36, and so on. It amounts to teaching someone random mathematical facts in a frankly scattergun way, often without motivation for why this is an important thing to learn, leaving the systematizing and meaning making part to the student as they struggle to memorize, rather than to understand. A good example is that a professor wrote a text to teach introductory calculus from the concept of a derivative downwards, where the rules of derivation are special cases of derivation, rather than the bottom-up way where we teach the epsilon delta proof, then the power rule, then the division rule, then the chain rule, etc. It's a different paradigm to start at the concepts. Derivation is the calculation of the instantaneous rate of change. Integration is the accumulating of infinitesimally small parts into a whole. The fundamental theorem of calculus means that these are operations that undo the other, and then work your way down into examples and practice problems and special cases. We also don't explain the process of mathematics, nor the grammar of it. So to speak, mathematics has objects or entities, numbers, groups, etc., operations that manipulate things, addition, derivation, etc., facts, the definition of an even and odd number, what defines prime numbers, etc., representations of entities, numerical, analytical, visual, etc., axioms, theorems, proofs, and common techniques of proof. These all should be taught explicitly, rather than letting students muck about in a mire of arbitrary rules for decades before they finally, if they ever, make these realizations for themselves. Particularly mathematical reasoning, proof writing. A great example of this is that when we teach children arithmetic, we aren't teaching them mathematics. We are instructing them in memorizing an algorithm that manipulated squiggly lines. We never address the fact that we are teaching an algorithm, one that performs a mathematical operation, in the field of mathematics called arithmetic, which is a field the concern of which is combining and dividing values. And the results of that are multifarious and often negative. The algorithm becomes addition to most people. Mathematics is reduced to these algorithms. And the perception that mathematics is algebra or arithmetic takes hold, when that is completely askew to the entire essence of mathematics. It also interferes with the identification and development of mathematical abilities. We see a student with a facile mastery of superficial numerical reasoning. They get put into honors classes. They get additional resources. They participate in mathematics extracurricular and competitions and boot camps. All of the time not demonstrating talent for mathematics, but rather a talent for, at best, numerical reasoning, and at worst, memorizing arbitrary rules and facts. This talent is closer to the skills of being a lawyer than a mathematician. Although there is obviously some overlap. And, I'll make a perhaps overly bold claim, there is a reason so many historically great mathematicians studied the elements as their first text, with its emphasis on reasoning and proving, rather than the modern shift to textbooks that teach in the way that I'm describing. I'll go perhaps even further into speculation, and say that I think this is partially why mathematics relies so heavily on prodigies, more so than other fields. To be a mathematician is still a lightning in the bottle intellectual proclivity that we don't understand well, and have erected significant barriers to achieving greatness within. How many more great mathematicians would there be if we changed how we taught it? 1/3. Depends on the age, I suppose, but for me video games was a large part of it. And grandparents who played card games like a religion, and a mom that bought me 6,000 board games. Mostly at garage sales, but hey, all of those require basic math skills, depending on the video game. But I tended to play the RPG and strategy games, and more often than not you had to calculate things. I swear learning blackjack at 4 years old did more for me scholastically than any one class 1 took. By the time I got to algebra, I was already informally doing it. Now there were just letters too. I had a board game that was peak 80s called Bargain Shopper, where you would run around a mall and buy things and sell them and use credit cards. Even had a credit card reader that was basically a lever and wheel prop with chances of paying less or nothing. Lots of math with that. And I was fixated on how to consistently win in the face of random chance happenings. Make it so math is more than a chore and it has a better chance of sticking emo. This will be hard to explain, but I'm more inclined towards engineering. It helped me to think about equations in a more mechanical way. I'm not sure why, but that made a lot of sense in my brain and that helped a lot. Genuine tip. Install Killer Sudoku on your phone, the most famous one, and go to expert mode where it doesn't show any number. Enjoy. To state the obvious, don't use any calculator. After a month or two you'd naturally be better at calculating basic math skills anyway. Start with the basics. Begin by reviewing the fundamental concepts and rules of math, such as addition, subtraction, multiplication, and division. Practice regularly. The more you practice, the better you become. You can use online resources, textbooks, or workbooks to practice math problems. Identify areas of weakness. Identify areas where you struggle the most, and focus on improving those specific areas. Learn from mistakes. Analyze your mistakes, and learn from them. Don't get discouraged by mistakes. Instead, use them as an opportunity to learn. Use real-life examples. Try to apply math to everyday life. This can help you understand the practical applications of math and make it more interesting. Seek help. If you're struggling with math, don't hesitate to seek help. You can get help from teachers, tutors, or online resources. Build a strong foundation. Building a strong foundation of basic math skills will make it easier to learn more advanced math concepts in the future. Be patient. It takes time. I think you should go about it the same way you'd go about learning everything else. Learn the theory, do practice cases, and when you feel like you've sort of gotten the hang of something, move on to something a little bit more complex. My field of work is mostly medicine, but lately I decided to join a course for statistics, and after going through all the anxiety and panic in the world, I realized that learning how to work with numbers required pretty much the same strategies I used to learn everything else. Learn to simplify things. Bonus: make everything in terms of tens, twos and fives. 18 times 6 equals 6 by 20. 6 times 2 equals 12,012 equals 108.
If you enjoyed this video, please check out our playlists full of similar content. Epic Eracast is like doom scrolling for your ears. Please like, share, and subscribe.